Hey everyone, thanks for tuning into the METUS Tech Show. On today's episode, we'll be talking about the inverter troubleshooting in the 4250 error code. But first, the METUS Minute.
Today's METUS Minute is on refrigerant sensor error codes for M&P equipment. There are 3 different error codes related to a refrigerant sensor problem. The first is 1521. A 1521 error code indicates that the indoor unit refrigerant sensor has detected a leak. If on a wall mount, floor mount, or one-way cassette, the indoor unit left lamp will blink 3 times and the right lamp will blink once. If this is the case, the source of the leak must be found, corrected, and the system properly recharged. The refrigerant sensor may reset, but will still need to be replaced. The next error code is a 1522. This error code indicates that a leak was detected, but not at the unit you are looking at. For example, on a smart multi with 2 4-way cassettes and a multi-position air handler, if a leak was detected at the air handler, the controllers for the 4-way cassettes will show 1522, indicating that the system detected a leak but not at those units. The final error code is a 5558. This error code indicates that there was a sensor error. For wall mount, floor mount, and one-way cassettes, the indoor unit left lamp will blink twice and the right lamp will blink once. This does not mean that the sensor has actually detected a leak, but rather that the PCB for the sensor may have a failed component. If this error occurs, check pins 1 and 4 on the control board going to the sensor on either CNSA or CN147 and verify that there are 5 volts DC going to the sensor. If there is 5 volts DC going to the sensor, replace the refrigerant sensor. If there is not, replace the control board. Thanks for listening to today's METUS Minute. Now let's start the show.
The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
I like how you guys bounce back and forth between heat pump talk and food talk.
The METUS Tech Show.
Mitsubishi.
Okay, so there's this weird fruit I used to eat as a kid. My mother used to get it. I don't remember what it was called, but it looks like there's a flower petal, like a big puffy flower petal, and you peel away the petals, and inside there's this little orange or red little thing. It looks like a cherry tomato, but it's kind of hard.
Yeah.
You know what that is?
Well, ChatGPT does.
Yeah. And what does that chat thingy tell you?
So I looked it up, and I still don't know how to pronounce it. It's physalis, Physalis, but better known as gooseberries.
Gooseberries.
Yeah.
Did you ever have gooseberries, Scott?
I never did.
No. So you don't know what they taste like?
No.
Now, I want to say, so when I was a kid, we used to have a grapevine in the yard, and late August, early September is when the grapes are ready, the Concord grapes, nice and purple,
right.
Very sweet. My father used to make wine, but before that point, like in late July, early August, the grapes are hard and they're green. They're kind of like mini Granny Smith apples. I used to love those. I used to eat those all the time. And that's what I think the flavor might be, like a little bit sour. Really don't remember. But they were so I was having this discussion with somebody just recently about weird fruits. And there's another one, I forget what the shape is, but you cut it open, it looks like paste. Okay. With a bunch of black dots in it, and it's a disgusting flavor.
Yeah. Dragon fruit?
Dragon fruit, yeah. That's disgusting. I don't know. It shouldn't even be a fruit.
Yeah. I've had it once. To me, it's like floral watermelon. It's very watery. Like, it doesn't have a strong flavor like watermelon. Like, it's mostly water, and then it has this weird... and I don't like the texture either. It's very gritty.
Like, watermelon's one of my favorite fruits. I could eat watermelon. Yeah. The only thing about watermelon is you have to know how to look at the watermelon, the stripes on it, because I got to tell you, I think my wife this season so far has bought like maybe 3 or 4 watermelons, and 2 of them stunk, no flavor whatsoever, and the other 2 were nice. But she has a way of telling by the stripes, and the yellow spot.
I'm gonna say there's a yellow spot thing too. I think.
Yeah. She has a whole guide that she uses, and sometimes she gets it wrong. But there's another fruit my sister-in-law used to put in her salads when she had us over for dinner. Star fruit, which looks like a star, but I don't know. To me, it tastes sort of like, I don't know, orangey.
Okay.
Maybe. I don't know.
Yeah. I've seen them, but I've never tried one.
No, of course, kiwis are good. But
Love kiwis.
Kiwis, the thing about kiwis is I might be allergic to them. They make my throat itch.
Yes.
Kiwis and peaches make my throat itch, but I still eat them. What other weird fruits do you remember?
Well, it's funny because when I was a kid, I ate so much kiwi. Like that was like my go-to snack. They're also really affordable. Like you can get like a thing of kiwis for $5 and they'll last, all month. But I ate so many of them that my mom actually got me this little plastic knife, and it was one side of it was serrated for actually cutting it in half, and then the other side of that same knife was a spoon, so you could eat it.
Yeah,
So that's how I used to have my little snack. I'd have my little knife, and then somebody introduced me to peeling a kiwi, and that is a game changer because when you cut it in half and you're still eating like through the flesh, right? The flesh is on the outside. You don't get all of it. But if you peel it, then you can just take a whole bite out of the fruit. Oh my God, it's so much better.
See, I just saw recently a video where somebody cut the top of the kiwi off and scooped it out like you do an avocado.
Yeah.
Which avocados I think are fruits too, but it's disgusting.
Yeah.
But I don't like avocados. I don't like the texture. I don't like anything. And there's another one. There's one that always reminds me, you break it open, and it's like all these little bugs are inside. Like you're breaking open a hive full of bugs, but they're not moving. It's got all these seeds in there.
Yeah.
Pomegranate.
Pomegranate.
Which is supposed to be very good for you. Mm-hmm. Right? And I like pomegranate. It's got a sweet, tart flavor too.
Yeah. Do you know they call those arils? Those the little pods of fruit? They're called arils. ARRILS.
Okay. Well, I've learned something.
Pomegranate arils.
Just learned something that I'll never need.
You will never have to care about.
Yeah, no.
I've actually had those gooseberries before too. At the grocery store, they have them like in a small container, like a really small one. But you're right. I mean, they have the texture of a cherry tomato. They're like waxy on the outside. They have that firm pop. But then on the inside, it's like sweet and tart, or citrusy kind of with that tartness. But
I'm gonna have to buy some because I've been like I said, I was a kid.
You'll see them.
I was a kid when I remember seeing them. There's another one.
You don't do grocery shopping though, do you?
I'm not allowed to.
Yeah,
because my wife says to shop on the outside of the store. Yeah. She goes to the produce and then the dairy, and I go straight to the meat section, and then I always ask, "Where's the bad stuff?"
Yeah,
the cookie aisle, the chips.
Yeah.
The stuff in the middle you really shouldn't eat. And I've learned a long time ago, never go to the grocery store when you're hungry.
Oh, yeah. Yeah. You'll come home with some weird stuff. It's like when I buy those, do you remember, this was when I was a kid, maybe not so much when you were a kid, but they came out with this stuff. It was in a jar, and it was peanut butter and the jelly in the same jar.
Yes.
Goober grape.
Yep.
That, like, when I go to the grocery store hungry, that's the kind of stuff I come home with, is goober grape. Because I'm like, I haven't had this forever.
Yeah.
And then it goes bad in my cupboard.
Yeah. No, that's, things. I used to love that because it just, there was a period when I think when the kids were little, it just makes life easier.
Oh, yeah.
But then my kids were like, well, we want strawberry jam, not grape jelly. Okay. So they changed that. So. Yeah. So I can't remember the last time I had grape jelly in my house. It was strawberry jam's what they like.
Yeah, I switched to strawberry. And when I was a kid, it was always grape. And then at some point in my adulthood, I switched to strawberry.
And I may be imagining things, but I seem to remember seeing squeezable grape jelly.
Oh, yeah.
Which is probably, and I just recently, thanks to Diana Kako, one of our sales folks in the central business unit, she just explained to me the difference between jelly, jam, and preserves.
Okay.
So jelly is just the fruit juice, and you boil it down and put sugar in it, and 50-50 juice and sugar, and then it congeals, and then you jar it.
Sure.
And then jelly is
jelly or jam? Because you just said jelly.
Well, that was jelly.
Okay.
Right?
Jam.
Jam is actually the fruit, and it's mashed up and cooked, and there's some sugar. I want to say, I could be wrong. She's going to probably yell at me. But I think it's still the 50-50 sugar. And then preserves is the whole fruit kind of chunked down, boiled down a little bit, or crushed, and then less sugar. So jelly's the worst one. You don't want the jelly.
Right,
That's not good for you. I think preserves are my favorite.
Sure. That makes sense because the pricing structure falls in line with that too, because like preserves for whatever reason are $7, whereas the same size of jelly is like $3.
And then I got a guy down the street from me. I forget where he works, but he's always got extra produce. And chickens love blueberries. Okay. So he's brought me like 10 pounds of blueberries before, where the expiration date is in the next week. Yeah. Which, sidebar, that's just a big scam. All right. So my wife, we can't, there's so many strawberries that chickens can't eat them all. But now the next time he does this, I'm going to make preserves. I'm going to put it in a pot, a little bit of water, a little bit of sugar, boil it down, smash it. Yeah. And I'm going to jar it. And I know I can peppers all the time. So the same thing. You put them in jars, you seal them, and good.
Nice. Yeah. I think the weirdest fruit I've ever tried, or not weirdest, but more exotic fruit that I've ever tried was a passion fruit.
Yeah, passion fruit's okay. To me, it's a little too sweet.
Yeah, it's very sweet. Yeah, for sure. What I like about it is, because I never knew, I just bought one. I was like, oh, passion fruit, I'll try it. And it got this like almost like orangey rind on the outside, but a little bit more firm, like almost harder. And then when you cut into it, all that's in there is like this yellowish paste with black seeds in it.
Yeah, I know.
And you just eat that yellow flesh juice. It's like gooey and whatever, but it's like floral and fruity sweet, and it is so delicious. It's one of my favorite flavors.
I know a lot of people who are from Brazil, and it's maracujá in Portuguese, and it's a big thing down there. They all love it. They have liqueurs and soft drinks and stuff. Scott, any weird fruits?
Persimmons.
What the heck is a persimmon? I've heard the name, but I have no idea what that is.
So it's a small fruit, like a cherry tomato. Yeah. It's very stringy, but the flavor is like an apricot.
Oh, I love apricots.
So where we're at, the deer love them. So that's why we like them. We like the persimmon trees for the deer. But if you're familiar with a persimmon tree and you find someone that's not, you pull a persimmon off the tree when it's not ripe and give it to them. It instantly makes them pucker and dries their mouth out.
Really?
Oh, yeah.
Oh, sounds like something I might want to do to my kids. Here,
you want to eat them after they've fallen off the tree.
Okay. Yeah.
And they've got a very good flavor. I don't like the texture of them, so I just get the flavor out of them, spit them out. But one of the old farmers always used to say, you can look at the persimmon seed, you dry it out and cut it in half, and it has a fork, knife, or spoon in it, and that predicts the winter you're going to have. Huh. So if it has a spoon, you're going to be shoveling a lot of snow. A knife is going to be cold, cut through you like a knife, and a fork is just rainy.
See, when I hear those types of things, my first instinct is to say, well, that's a bunch of hooey, malarkey. But then I used to know these old timers. Like I said, I had a grapevine, and my uncle was I was a little kid, and he was old, and he would say that you have to come and prune a grapevine the day before, the day of, or the day after a full moon. And if you don't prune it in that 3-day period, then you're not going to have good grapes, which means you don't have good wines. And I mean, and he's probably the 10th generation in his family who believe that. And I don't know if there must be some science behind this or something, but I don't know. Yeah. But one last fruit is a fig. I love figs until I found out how they're pollinated. Okay. So most fruits and flowers are pollinated, butterflies, bees, and things like that. Sure. Well, I'm going to say, I forget what it is, but let's just say there's 600 varieties of fig. Well, there's 600 varieties of a wasp that pollinates that fig. And they pollinate the fig by boring a hole and nesting inside the fig. And then they die there and they're part of the fig. So
really,
that's what I was told. It could be a bold-faced lying, but I'm going with it. But it kind of turned me off of figs.
Well, I'd eat them anyway.
Yeah, I don't know.
Probably protein in there.
Yeah, protein. Anyway, welcome to the METUS Tech Show. My name is Paul Shavs. Joining me in studio today is Bryn Raptor. Bryn, say hi. And our special guest, Scott Shipley from Trane. Scott, tell us where you're out of, what do you do, your title, and anything else you want to say.
I'm Scott Shipley from St. Louis, Missouri. Ductless Technical Specialist is our actual title for the Trane employees. I've been 7 years at Trane now. Do just the VRF post-sale support. So teach the city multi-class as well as make sure jobs get installed properly. Job site visits, I assist with startup and that kind of thing. And any problems that come up, the technical support side as well.
Yeah. And you're also an authorized trainer.
Yes.
All right. That's important to know. And by the way, for those who heard the term DTS, for us, that's the same thing as DSG. They're one and the same. They're synonymous. So for the Trane side, we call it Diamond Technical Specialist, DTS. Legacy side is DSG, Diamond Service Group. For us, they're the same. You're technically part of the Diamond Service Group.
Right.
Yeah, that's good. So tech support, teaching, job site visits, and so on. So, Bryn, what are we going to talk about today?
So I thought today we could talk about the 4250 error code, which is a pretty vast error code. There's a lot of things that could come of that, but really it's kind of to start the conversation just about inverter checking in general. And we've had episodes on that in the past. So this is just more of a focused version of that, where we're going to talk about the steps specifically laid out for a 4250 error code and maybe some things that we may want to consider along the way.
Right. And the good thing about this is the steps that we're going to go over here, they can be applied to any error code, regardless of what the 4-digit is. So I always I like to tell people Control F is your friend, because our manuals are electronic. They're PDFs. You open up your computer, you hit Control F, it brings up a screen. We type in 4250, we hit enter, and you just keep hitting next until you find the error code definition page. In this example, and this is the NGen. Correct. The NGen manual. So in this example, if you open up the PDF, you type in the 4250, you're going to come to page 7. Well, the page number doesn't matter, but it's going to be section 7-6-22, and it's going to say error code definition for 4250, 4255, and 4256. Yeah. And then it's going to tell you the error code definition is IPM error. It's going to tell you the detail code. So if you got maintenance tool, it's detail code 101. And then the error definition, it's going to say 4250 is an overcurrent. And it's going to give you a bunch of little circuits that you want to look at. But it says if you have 4255 or 56, it's the IPM error is the signal error, not an overcurrent.
Yeah, so the big thing is and why these are kind of lumped together, 4250, 4255, and 4256, is remember, with our city multi-equipment, we have 3 IPMs. We have our compressor's IPM, correct, which makes the simulated 3-phase to drive our compressor, but we also have simulated 3-phase driving our fan motors. So depending on whether or not it is a compressor-related IPM issue or a fan-related IPM issue, you're going to get that 4250 versus a 4255.
All right. So we're going to do a podcast. Actually, we already did a podcast, now that I think of it. We already did a podcast on acronyms. Yeah. And I don't think we put IPM in there. But for the sake of clarity, what does IPM stand for?
Intelligent Power Module. But it's basically where our IGBT lives.
Right.
Or IGBTs, excuse me.
Yes. Right. IGBTs, insulated gate bipolar transistors.
You got it.
Okay. Not that anybody needs to know that. It's just what it is.
We're already very acronym heavy today.
Yes. Nope. And none of these so far are in the episode we recorded with Metsui.
Oh, good.
Which will probably come out after this. No. Because we still have to edit it.
Yeah. Awesome.
I'm falling behind on that.
So one of the things that I just want to lay out is, so when you get this 4250 error code, you look it up in the manual, it's going to give you some causes and then check method and remedy. So causes are what has to happen in order for this error code to go off, and then the check method and remedy is how do you fix it. So one is inverter output related. One is model selection switches 5.3 through 5.8 on the outdoor unit are set incorrectly, and one is open phase in the power supply due to improper power supply wiring. Now, in order is how I just read them. So the first is inverter output related, second is dip switches, the last one's power supply. In my world, the first thing I'm doing when I see this error code layout is I'm going to look at my dip switches. Just because it's step 2 does not mean that I'm going to start at step 1 and then eventually get to my dip switches. Dip switches are easy to find the information for in the manual, and they're easy to fix if they're set wrong.
And that's the thing that's important here. You kind of need to use a little thinking, right? Because I imagine that the engineer who put this together was trying to think, this is what you should do in order. Sure. But as a technician, as a technician, I think you need to think about what is the easiest. Eliminate the easiest first. Yeah. Like, I'm not going to check the incoming power last.
Right.
Exactly. So you kind of have to have a little bit of troubleshooting experience and understand. Dip switches, you're right. That's just a visual look without any tools, maybe a flashlight.
Yeah, compared to your service manual.
Yeah.
It should be good. The other thing, too, is depends on when it happens, right? If it's a unit that's brand new, it's just the first time you've ever flipped on the disconnect, I'm probably going to go right to step 3. What are the odds that the inverter board actually has an issue right on startup? It's unlikely. What is likely, though, is that the wrong power supply was provided, right? Or a control board was just replaced. If a control board was just replaced and then you'd go and flip on that power, you get a 4250, I'm probably going to check my dip switches because they all get shipped off on a control board. So when the error happens, it may play a role into which one you start with.
If this system's been running for years without an issue and nobody's been there, if you know that for a fact, chances are the power's good. Could be. And chances are the dip switches weren't changed. They didn't change themselves.
Yeah.
So then in that case, you would look at the grid. It's just a bunch of boxes, and it would say inverter output related. And on the right side, it says refer to the following pages. And these, I think I would do in order. Right? And the first one is go to section 8-10-2. And you turn the page. Listen. You turn the page, and you go, actually, I'm doing this on a computer. I just have these printed out because I can see them better.
Yeah. Right? Yep. But you'll scroll. It'll tell you exactly what section, which is 8-10-2. And you'll have to scroll down to find that part, but it will lay out the steps for checking the inverter board error detection circuit. And so what they're really trying to do there is just figure out, the inverter has safeties built into it, right? It has these monitoring components. And so what we're doing is testing that part of it. So without any wires attached to the compressor, let's just run the system so that we're not actually putting any load on the system and see if that inverter is going to go into error. So your steps for making that inverter check or that inverter board error detection is you want to stop the unit, turn off your power supply, and disconnect your wires from the compressor. Then turn the power back on and put the system into operation. And what you're doing there is you're trying to look at what error comes up when you have no wires attached to your compressor. So you may still get a 4250 error code, which would be overcurrent. In that case, it's going to tell you replace the inverter board, right? Obviously, with no load, we really should not have high current.
Right.
So if we are still having high current, it's likely there's a short somewhere in that board. So it's going to tell you to replace the inverter board.
It really can't be anything other than the board.
Correct. Yep. You could have a logic error, which would be a 4220. In that case, you'll still be replacing the inverter board. Or you could have an ACCT sensor circuit failure, which is a 5301. In that case, you're also replacing the inverter board because they're all one and the same. They're all different components on that board. But those ACCT sensors are looking at current through the inverter. We can view that actually through maintenance tool. So because we have that information, if it's not reading properly, you'll get an error code for it. Mm-hmm. And what you should get is IPM open. It's a 5301 with a detail code of 119.
And if you get that, it's not the inverter board.
You got it.
You move on, you go back to the initial page, and then the next step is to go to 8-10-3, which is checking the compressor for ground fault and coil resistance problems.
Yeah. So now this is where we get into your standard compressor diagnosing. This is not different from any other compressor you've ever diagnosed. We're going to meg it out, looking for shorts to ground, and we're going to ohm out across the windings. Now, the nice thing about when you check 8-10-3 is it will tell you the size of your outdoor unit and what you should get for resistance across the coils. So step 1, you're going to ohm each coil to ground using a megger, and we want to see less than 1 mega ohm or less than 1 million ohms. So find a ground. Usually we say copper close to the compressor, bare copper close to the compressor. We're going to go across U, V, and W and make sure that we have more than 1 million ohms. Okay. Anything less than that indicates we might have a short to ground.
And just as a tip, and I'm sure the seasoned techs know this, probably mostly techs do, but I used to take a little piece of sandcloth or sandpaper and make that copper nice and shiny right near the compressor. That way you don't have to worry about any of the buildup, the oxidation, or anything. It's nice and clean. So before you put your megger on it. Yeah,
and the other thing, which is what I thought you were going to mention too, is make sure there's no liquid in that compressor.
Correct.
And the reason for that is that liquid can behave
like
a conductor.
Yeah, it can fool you. It can make it look like you got a bad compressor. So it's got to be heated. You got to make sure it's powered at least. Typically this is going to be a winter problem, but you never know. Make sure the power's been on for at least the 12 hours so there is no liquid in it.
Yeah. Yep. So once we've checked for shorts to ground, verifying we have more than 1 million ohms, we then are going to go across the windings, U to V, V to W, and U to W. Now, the amount of resistance we should get is going to depend on the size of the unit, but also the voltage. So we want to make sure that we're checking the correct unit. So if I'm looking at a 72 or 96, a 460 unit should ohm out around 0.72 ohms, whereas a 208 unit is 0.2 ohms.
And it's all written right there in the chart.
You got it.
For you.
Yep. It's all laid out.
All right. So if 8-10-3 checks out, we're not going to go to 8-10-4.
That is checking the inverter for damage at no load.
So what are the steps we're going to follow there?
We're going to stop the unit, remove the power supply. We want to disconnect the inverter output wires from the compressor terminals, as we did in the previous step. And then we want to turn switch 7-1 on. And that's going to tell the board that there's no load. We're telling it there's nothing connected. And then we want to apply power and then put the outdoor unit back into operation. And then check the output voltage after the inverter output frequency is stabilized.
Yeah. So, what we did was we removed our wires and we just ran the system first to see what was wrong with if there was an issue with the IPM, right? Or our inverter board, excuse me. And the hope is that we got an error code saying that there was an issue, right? It was saying, hey, you don't have a load on your system. If we get that, then we know, okay, my inverter is doing what it's supposed to do. Then we actually check the mechanical component, the compressor. We ohm it out. And if that all checks out, now we go, okay, what's going on here? Let's see what our voltage coming off of that inverter board actually is, right? And so this is the step that we're at. 7-1, like Scott said, we're turning on that dip switch to tell the system, hey, there's going to be no load on the system because we removed our wires. Otherwise, it would go back into that error code that we got the first time, right? On 10-2. It's going to give us that error, hey, there's no load on the system. So when you turn on 7-1, it bypasses that and says, okay, they're doing inverter check. Doesn't matter if there's no load. So the one thing you want to do is make sure you put the system into a test run. And the reason for that, right, you pick an indoor unit or a couple indoor units, put them into test run, is because you want to make sure that your compressor frequency stabilizes. Because what can happen when we're in normal operation is we've got variable frequency. And so what we're doing here and what we're about to do is check for balanced voltage coming off of our inverter board going to that compressor.
The easiest way to put in a test run, in my opinion, is maintenance tool.
Yep, absolutely.
Why would you do anything else? Connect maintenance tool.
You don't have one.
Test run. Well, if you don't have a maintenance tool, get one.
If you don't, you can do dip switches at the outdoor unit for a test run too, which I think we've talked about in previous episodes.
I think
but
we did.
We're looking for balanced voltage on those terminals. And so when we are checking for balanced voltage, typically they say plus or minus 5% on our city multi-equipment. Typically residential, you'll see plus or minus 10, but commercial, they're a tighter tolerance. We want that plus or minus 5%.
Yeah. Even on every test that I've ever done, it's always been way under 10%.
Yeah.
Even so, never. It says plus or minus. It's usually right. It's usually 1 or 2%.
Yeah, it's like 1,000%.
Yeah.
Typically.
So just it should be fine.
And the reason why, like I was saying, with the test run is if you have a compressor that's got variable voltage, right, and it's your normal operation and your inverter IGBTs are switching at different rates to try to meet some sort of load, when you're checking across U and V, and then you check to V and W, and then you check to U and W, that voltage may have changed because of the compressor's nature of wanting to ramp up and down. And so that's why that last step says when that output frequency is stabilized, because at that point you should, your voltage shouldn't change, and it gives you more time to check without them jumping around.
And that's important because you could misdiagnose it if you're not aware of that.
Absolutely. Yeah. And so that's all we're doing there. And then the steps as far as that goes is if you have an inverter voltage, if you have no output on U, V, and W, right, that's a major issue. We need that balanced voltage. It's AC voltage. The natural voltage itself doesn't matter as much. You can see the range in the service manual. You can locate it, but we just want to make sure that there is AC voltage. If you don't have any, then you obviously have an inverter board issue. The only other thing it would be is maybe a wire issue. Just check and make sure you have continuity on your wires at that point too. If you have unbalanced voltage, right? So we check across U and V, you've got 100 volts. You check across V and W, you've got 105 volts, and then you check across U and W, and you have 107 volts. Well, we're not balanced, right? We're outside of that 5% tolerance. That's an inverter board issue where our IGBTs aren't switching. You may find that one of those IGBTs is no longer switching, and so we're not getting that balanced voltage. And then if you have no voltage imbalance, that means it tested good, right? We're good to go.
So the first 3 steps, if it, I'm sorry. I just got distracted. I saw flashing lights out there. I thought it was an ambulance because you never know at my age. People could call an ambulance on me. But anyway, you're replacing the inverter board if you got an imbalanced voltage. And if everything's fine, the inverter board's good too.
Yep, absolutely. And it verifies your wires are intact.
Yeah. So that was 8-10-4. And all we're doing is going along. We're back to where we found the original error code. And we're looking at the grid there, the boxes, and we're just following along step by step, eliminating what's not wrong till we find out what is.
You got it.
So that was, like I said, 8-10-4, and if everything checks out good, everything's normal. Now the next one is 8-10-5.
You got it. So at 10-5, we are hooking our wires back up to UV and W, obviously with the power off, and we're actually going to turn the system on and put it into operation. So what we're looking for now is the entire scope, right? We've tested our inverter, we've tested our compressor, we've tested our inverter with no wires attached. Now we're actually attaching those wires. What's going on? What happens next? And some of the things that we're trying to verify there is that before we even start, we want to make sure that our system's equalized, so our high and low side pressure are the same. We want to make sure there's no liquid refrigerant in that compressor. And then when we put that system into operation, we need to verify that there is a pressure difference between high and low pressures. So this is how that system determines whether or not the system has load, right? So as it starts up, it needs to pretty quickly see like a 14 PSI difference between the high and low side. If it doesn't, we get that inverter error. So we're verifying that happens. We're going to check that high pressure LED. You can do it on the LED or you can do it through maintenance tool for changes. Because now we're starting to think, okay, do we have like a free spinning compressor? And is that why we're getting these errors, right? We're not building compression because something's mechanically failed internally. Maybe we're not shorted, but something in that motor, the compressor motor, has failed. And then again, we're going to check for that balanced voltage. And we want to make sure that we have that balanced AC plus or minus 5%.
I just like to sidebar here for a second for 2 things.
Yeah.
First of all, there's a video on our LMS. You go to MitsubishiComfort.com, you go for pros, go to the training, and there's a video there that we have on why compressors fail. Mm-hmm. And it's a very good video and explains exactly what would cause some of these mechanical issues there and these breakages. And the second thing I want to mention is if you noticed, we're talked a few times of power it down, power it on, power it down. So you can't be in a hurry with these things, and it's going to take some time. Every time you power down and power back on, you're going to wait for things to flag out. That could take several minutes. If it's a very large system, it's going to take longer. So you got to be patient. If you expect to be in and out of a service call in 20 minutes, it's not going to happen.
Yeah, I mean, especially not with a 4250, because as far as I'm concerned, it's a hardier system, right? Right. When you go to the doctor, if they check your blood pressure, it takes 5 minutes, right? Maybe. If they're going to do open heart surgery on you, it's going to be a whole day thing, right?
If they give you an EKG, if they give you an EKG and there are issues, they're not going to let you go anytime soon.
Right.
They're going to sit there. It's going to take them a while to find that. Not that I know this from experience, although I do know this from experience.
No.
Yeah.
So we're just basically making sure that we get that pressure difference. And this, again, is just checking the actual function of the compressor now. Now that everything's hooked up, are we actually moving refrigerant around? Are we building compression, right? So we're testing some of those mechanical aspects of the compressor that we can't necessarily test via a meter. So continuing through 10-5, we want to make sure that no overcurrent errors occur. And if they do, we need to go back and take some steps for checking the converter for damage during compressor operation. That's another step. If it occurs immediately, we want to make sure that the compressor's not flooded. We want to make sure, again, that we have that pressure difference. If we get an over voltage during operation, we want to go back to that 10-6 that talks about checking the converter for damage during compressor operation. So what can happen potentially is we have too much DC voltage, and that's why we're getting this overcurrent on the AC side once it's switched over.
Yeah, and this is important, getting back to when this happens. If this is on a startup and you get this, and this actually happened to me, my very first service call with Mitsubishi, Jerry Flynn and I were out in Minnesota, and it was a school. They went to start the system up. They had just powered it on, which we didn't know that. And this was the one that was overcharged by 56 pounds.
Yes. Yeah.
Right? And that's exactly what had happened. And now I got to tell you, I was sitting there at the outdoor unit and I heard nothing. There was no noise that I heard, and just waited a few minutes, and then the error code popped up. Right? And it was like, okay, what is this leading to? Luckily, Jerry was there because he had been doing this for years. I was here, I think, 3 weeks at the time. Right? And he said, oh, yeah. Then we started asking questions. How did you charge this? And they charged it by throwing gauges on the old-fashioned way. Yeah. The old-fashioned way until by superheat.
Yeah.
And, and this was October in Minnesota. It was probably in the 30s outside. The building was vacant, and they were bringing fresh air into the building. It was probably 30s inside.
Wow. Yeah.
And they were trying to just get the back pressure up.
Yeah, it doesn't work that way.
And then the only good thing they did is they kept track, which you're supposed to do. I think it's a requirement, federal requirement. They kept track of how much refrigerant they put in. And we went and compared it to how much they put in versus how much it needed, and it had 56 extra pounds. Which the scary part is that's not just one jug.
No. It's not. But.
So anyway, all that to say, again, it's when this fault happens.
Yeah.
On a startup, I'm looking for things a little differently than I am if this has been running for a while. I wouldn't bother with this one if no one's been there and it's been running years. I mean, running fine for years.
Potentially,
I'm probably not going to look at this one that hard.
Yeah. What you might see too is that, if you have something like an overcurrent immediately after compressor startup, because you're overcharged, right? There's just too much liquid, and it's sitting inside the compressor. So it doesn't take long for the compressor to say, whoa, or the inverter board to say, well, we got a problem. Whereas if it takes 15 minutes of operation before something happens, then you might start looking somewhere else. So that's another thing too, is just pay attention to when that error code actually occurs, because it may indicate different things. So now that we've checked everything on 10-5, we can jump over to 10-11.
So 10-11 is checking the installation conditions. So we got to check the refrigerant charge. Paul already mentioned comparing it to DSB, Diamond System Builder, making sure the as-built line links were put in and we know what the charge should be and we know what was added. Right? That's a very critical step. And then we want to make sure that the outdoor piping rules have been followed according to the install manual. If we've got a twinning kit, all those things, the pipe coming to the unit, we don't want it angled down.
Right. Yeah, and that's one of those things because, you'd actually probably have good insight on this, but, what I hear a lot from contractors when they're in class is that when they get the original DSB, it's kind of a very rough layout of where everything's going to be. So they have all the units, and they have arbitrary piping lengths, they have arbitrary charges, and then once everything's actually been piped, it gets confirmed through, sometimes it's a DTS, sometimes it's a distributor, sometimes it's a sales or an engineer, but somebody actually finalizes that Diamond system build and tells them, okay, this is your charge. Now, I would imagine that at some point it has to have happened where they pipe it the way they assume it was supposed to be piped, and then they realize, my piping length to my branch controller is way too long. Where they go from the outdoor unit, they say this is where the branch controller is going to be. They run the piping and they find it's too long. And really, they could potentially go through some of that install before it gets put into DSB, and DSB flags you.
And this is why it's important. And I tell this to people: if you're the installing contractor, if you're the install crew, and you're showing up to this job site and you don't have a DSB, don't start the install.
Yeah.
I'm serious. Don't start the install, because what you want is to have that with you. Because the guy who came out and looked at it, and he's estimating, I doubt very much that they're going to give you precise measurements. They don't know exactly where the pipe's going to be run. There are always things that change. Somebody put a wall, we didn't expect it. There's a beam, we didn't expect it. They put a doorway here. So the guy who comes out the first time is going to do the DSB as a plan.
Right.
And we all know, when I ask this, what what are the chances on any job site that everything goes exactly according to plan? Mm-hmm. It's always a zero chance. It's never 1 or 2%. It's always 0. So that person is going to guess his best guess, and he's probably going to guess a little higher. Because if I think it's going to be 10 feet, I'm putting in 15. Yep. If I think it's going to be 80 feet, I'm probably going to put in 90 or maybe even 100 because I want to err on the side of caution. Yeah. So now you're the installer, and you're going to run that pipe. You think you're going to get an exact measurement. You're going to know. You're going to have a much better idea how long it is, and you're going to change that in that DSB. Because the worst DSBs, the ones I hate to see, are the ones with 0 feet for every single measurement. Yeah. Because now you have no idea if this is going to work or not. You want to find out before you run that pipe. Because if the max, I'm going to make up numbers. If the max is 100 feet and you put 110 feet. It's going to tell you you've exceeded the maximum length. Right. You don't want to run the pipe and find out after that you've exceeded. Right. Exactly. Because we all know, we've all been there. I don't care who the contractor is. I don't care who the manufacturer is or what kind of job site is. If it's installed wrong, it's going to stay installed wrong. Very, very rarely do we come out and start over again. Right. Which is the right way to do it, but it's not going to happen.
The other thing with that is elevations. A lot of guys don't put the elevations in there, and your length will change based on your elevation difference.
Yeah, and whether or not the condenser's above or below, if it's on the ground or on the roof, that makes a difference as well. So the guy who's designing this has put that in, but and the people installing it, they got to have the DSB there on a computer, and they got to put these numbers in. Yeah, it's going to take a little bit of time, but it's going to save you so much. It could save the whole profit on the job. Yeah.
Now, Scott, do you assist with building DSBs, or is it you kind of come in after that's already been done?
I usually come in after that. Okay. I have built them. I've got contractors. Most of them don't want to do anything with DSB. Right. So they'll just give me, we'll print off the piping diagram and they'll write the as-builts in there. Sure. I did just have a contractor working on a sorority house that had the DSB, and he was putting in his as-builts in, and he kept getting an error for piping length. And we did determine it was because the elevation, there was 4 sub-BCs. Yeah. And the elevation between the BCs was 3 feet too far. And so it was limiting the other equipment. So it's nice when they have it and they can do it. Most guys, I don't want to mess with that. But I've had guys on jobs where they've told me, my as-built, it's 30 feet from the BC to this unit. And I go out to the job and I can touch both units. Right. And I don't have a 30-foot wingspan. Right. Yeah. That gets overcharged really quickly.
Yeah.
Now, the sorority house, it wasn't occupied. No, never mind. We don't
What I find, too, I typically when contractors, I've even had them show me some, and they're like, yeah, this is what we get for a DSB most of the time, and it's every indoor unit's 35 and 0. 35 feet, 0 bends, everything's at 10 feet, and the problem with that, again, is that when they start building, they won't catch if they're exceeding piping restrictions unless they want to sit down and read the manual with all those formulas. Yeah. Right. So, I always, especially if you've attended the 3-day classes, make sure that, or if you can, have a physical copy of the DSB, but also the digital copy that you can make changes to on the fly. Yep. So then as you make those changes before you get done with the entire piping and then send that info off, you can catch it and go, whoa. We're already breaking the rules. We got to fix something. Yeah. And then get in touch with the sales or engineer and make those corrections.
And that's what I like to see. Every contractor is going to get a set of the building plans. And to see a printout, somebody printed these out as part of the plans. It's a big, giant sheet, and the DSB is there. Yes, writing in the actual lengths is what you need to do, and that'll save you time later if you do it as you go along. And there's no need to be concerned unless the length that you're putting in exceeds what's written there. That's why hopefully the guy who's estimating these lengths is going a little bit higher than he needs. Right. DSB will warn him if it's wrong. But if you're putting in less than what's there, then, hey, you're okay. You don't need the computer copy. But if you keep putting in higher, longer than what's there, or if they're all the same lengths and all the same bends or 0 lengths, then you need that computer copy of that. I'm sorry, you need the digital copy, and you need to rebuild this in. Yeah. Otherwise, and rebuild it. Take a better guess and rebuild it. Otherwise, you start this and you've exceeded it, then fixing it is going to be a lot harder.
Absolute headache.
And you as the company are going to lose all the profit on this job, and it's just going to be a nightmare. And no one is going to be happy. Anyway,
so that's more, that's one of those potential 4250 errors that really is more on the initial startup and initial installation issues where you got to make sure you check your charge, make sure that you're not exceeding any piping lengths. The last one's pretty quick, so we don't have to cover it too much, but troubleshooting problems with the IGBT module. If you go to that 8-10-15, it's going to lay out each version, basically each board of each inverter board, and it will give you a resistance to check across certain terminals, whether it's L1, L2, L3, or you'll see SCU, SCV, SCW. And typically what they're looking for is between 5 and 200 ohms for resistance readings there. And, so just make sure you refer to the manual for that particular section just because it is so varied depending on the type of unit or the type of inverter board. But it's just that would be your last check is actually making some resistance checks on the board to make sure that you don't have any failed components. So that's 8-10-15. At the end of the day, like we said, you get this error code, the first thing I'm going to go to is just make sure I didn't drop a leg on my supply voltage. Make sure your dip switches are set right, and then you can start digging into the actual inverter, right? Yeah. Do a couple tests with nothing attached to it, under no load, and then put some load on it and kind of work towards, when that error is actually occurring. Yeah.
Now, this is obviously it's an audio podcast. There's no videos to look at, and I realize that I'm going to assume or take a guess that most of our audience is listening to this while they're doing some windshield time, and that's okay. But if you're interested and you really want to know the procedure for diagnosing a city multi-piece of equipment, listen to this podcast with the service manual in front of you. Take an NGen service manual, go to your computer, hit Control F, type in the 4250 and follow along as we go through here, because then it'll make sense. Because I don't care what 4-digit error code you type in, this process is going to be the same no matter what.
Sure.
So it's just a good way for you to really know how the service manual works. It's speaking from personal experience. That was my struggle in the beginning when I was in a van and doing things like this. It's just not understanding how the manual works and how it's set up. Yep. That's half the battle.
Or the aversion to opening it in the first place. That's the other one that you have to get over pretty early.
Yeah,
you're never going to know everything about every type of equipment.
Yeah.
Right. It's not like everybody who listens only works on Mitsubishi. So you have to acknowledge, I'm not going to remember everything about this equipment, and get over the aversion to opening a manual and just commit to, okay, I got this unit, immediately get the manual up. You can still do your thing, right? But get the manual up and loaded. So if you need to refer to it, you can.
Well, I was very fortunate. I was taught by somebody who hammered home, read the manual, read the fantastic manual, read the fantastic manual, except they didn't say fantastic, right? So I was taught that as a young apprentice, so I don't have a problem with that. Yeah. I absolutely refuse to ask for directions, but I don't have a problem reading the manual.
Unless it's your Australian GPS lady.
Oh, yeah.
You'll listen
my wife says, why do you have that voice on there? I go, it's just something different, because she uses weird things like car park instead of parking lot. And what is it, instead of a rotary? Roundabout. Yeah. Instead of what we call up here in New England a rotary or a traffic circle.
Yep. So the other thing, too, is just because Paul was just talking about it, I think it's Spotify, is it, that does transcriptions of the podcast?
Yeah.
So that can also be a resource to you, is, this is going to have in the title that it's a 4250. So you walk up to a city multi-piece of equipment, you see a 4250, you may benefit from being able to just look at the transcription of this podcast and kind of sort out some of the
And I know I've mentioned this before, but Cole, he's from your neck of the woods. He's from St. Louis.
St. Louis area.
He actually told us he was here, that he had this fault. He remembered we talked about it. He searched it up on Spotify and he found the transcript. Instead of listening to the whole podcast for however long we babble on here, however long we do that, he just went to the transcript and read through it. Took him a few minutes, and he diagnosed it. He found what he needed. So that's something I didn't really know. So that's just another tool that you can use.
You got it.
Scott, any last words?
No, the biggest thing, and we were talking about the dip switches, and maintenance tool, right? You can look at maintenance tool and see where your dip switches are set. Yep. If you've got it. So that's an easy thing without having to get your magnifying glass and look at the dip switches for me.
Yeah.
And you can also use maintenance tool and save the dip switch settings for future use. So if you're installing it, you can actually have maintenance tool save that information for you, right? Keep it on file, send it to the office or whatever. But now down the road, if there's an issue and you were the installing company, you should have access to how were these dip switches set at startup. Again, depending on when any fault happens. If it's been running fine for years, has anybody been here? Has there been a control board replaced?
Right.
So everybody's got a camera on them. Before I replace a board, I'm taking a picture of the old board, not only to see where all the wires are plugged in, but to see what the dip switches are, and I'm going to put everything back on the new board the way it was.
Yeah.
Right.
But now you got maintenance tool, because that's actually happened to me in one of the training centers. When I used to run through this, and back then the extended warranty required you to take the dip switch settings.
Yeah.
And I did that, and it was in Chicago. And then one time somebody went in there and started messing with everything else. I just went to the computer, looked at the maintenance tool file, and said, here's where the dip switches, here's the positions they're supposed to be in, and boom, boom, boom. I didn't even have to look at the manual. It's just maintenance tool to do it. So that's a pretty handy tool.
Yeah. You can also look at compressor starts and run hours using maintenance tool, which can be helpful specifically for a 4250, where you can actually log it and say, hey, how many times has this thing started up? How many hours does it run? Like in our training center, we've got like 90 starts and I think like 250 hours, maybe not even.
Yeah.
So you figure that's not a good, if that was in the field, that's not good. I wouldn't be proud or happy about that situation.
Yeah.
But it can be helpful for, how long has this thing been short cycling? And, maybe you figure out it's a piping issue and that's why I'm getting compressor related issues. So just another way to help you out. But yeah, I think that does it for the 4250. I forgot to mention one fruit.
What's that?
It's the most bizarre fruit. It's called a tamarind.
That sounds familiar.
Yeah, it's a pretty popular thing. It's I think it's really popular in like Mexico or Puerto Rico, like in the Central America area. It almost looks like a peanut. Like if you look at it, it's like a long peanut and it has the two seeds in it like a peanut does. And all around it is this brownish flesh. It's gooey. It's bizarre, but it is so good tasting. It's delicious. But you have to like get over the fact that it's this really dried out shell. And then inside are these like two seeds that are covered in goo. But you eat the goo and it's delicious.
I can get over that. Who in the right mind would look at a lobster and say, I wonder what that tastes like? But I love lobster.
Yeah, it's true. It's true.
Yeah. Oh, should we talk about the sad news?
Sure.
Yeah. Scott Tallman is no longer with us. God rest his soul.
That's a lie. He's moving. He's not.
Well, he's not dead. He's just.
Don't say God rest his soul.
Well, he's dead to me. He moved on. I know. In all seriousness, I wish him luck. He's a great guy. He's one of the best people I've ever worked with. He's super intelligent, and he's gonna be missed. But yeah, he's dead to me now.
Yeah.
I wish him luck though.
What we're gonna do is on the logo, we'll just put a big X. Instead of just removing him, we'll put a big X through.
Well, we still have Roland on there, and he retired.
Yeah, well, that's because we talked about this last week in Orlando. Roland's spot in there is retired. Just like they retired Jackie Robinson's number. Nobody gets to replace his spot. He's retired there. That's what he can't be moved.
Yeah.
As long as our intro has him talking about a podcast for HVAC professionals by HVAC professionals.
That's right.
Then he's not going anywhere.
Yeah, so that's right. So Roland's the retired number, but Scott is more like Johnny Damon leaving the Red Sox to go to the Yankees.
Yeah, he's the enemy now.
He's dead to me.
Kidding. We love you, Scott.
Yeah, I love you, Scott. Take care. Bye, everyone.
Bye. We'll see you on the next one.